using subagents for implementation and review in your LLM workflow. What is it? Why would you want to do it? And how do you do it? That's the theme for this video. Hello, this is Bill from Shokin. I've seen so many videos on YouTube and so many posts on Reddit where when somebody wants to evaluate the quality of any particular AI model, they do this one-shot challenge where they have a piece of software that they want to build, and then they come up with this gigantic prompt that includes everything that they want this software to do, and they feed it to the model, and after a little while, or maybe a long while, they hope to receive something that's directly runnable. And I think the LLM community has converged on the opinion that this is really not a viable way of doing things. You know, in the same way that it's not viable for any serious software company to bypass all the product to implementation to review to hooks and tests and all of that. We're not there with AI yet. It's one-shotting is something that can only be done with trivial stuff like a hello world web page or something like that. In any production workflow, you would have the guardrails and the infrastructure set up to allow human software engineers to work together. You have to have the same infrastructure for that as well. Now, I have talked about this in one of my earlier update videos with regards to setting up hooks, setting up tests, setting up deterministic gates to ensure that the the AI agents are kept honest, responsible, and in check. This is particularly interesting if you're working with Claude. From my experience, Claude lies all the time. And if you have a hook that tells them, hey, this test failed, then Claude can't lie about that anymore. In any case, that workflow is still what I would consider the industry standard. In other words, you have to have somebody implement this, you have to have somebody to review it, and you have to have somebody to deploy it, right? These are all separate, in the same way that there are separate human tasks in the human world, they have to be handled by separate agents in the agents world. Now, the particular improvement I like to talk about today is using subagents to automate some of the friction away when you're using different processes in your LLM workflow. So it used to be the case that, at least for me, I would spin up a main implementer and I would spin up a new review agent. And when the implementer is done implementing, I don't want the implementer to review my code because the context that it has regarding how it reached this code that they've just written would pollute the results of the review. It's sort of like you wrote the code. Of course, you're going to like the code that you just wrote, right? You can't do very reliably adversarial code reviews with the agent that just reviewed the code. So I want somebody else with a completely fresh context to review my code. And herein lies the problem. It used to be the case, there are 2 codex sessions. And when the implementation agent is done, I ask the review agent to review. And when the review agent is done, I ask the implementation agent to check the review and make fixes. I become the glue. I become the handover between those 2 agents. And this is deterministic work. This doesn't require judgment. If this is done, do this. If this is done, do that. Why is a human doing that? Makes no sense. I tried different variations of making this work. And one of the things that I did try, which you should not try, by all means, go ahead and give it a try. Tell me if you've reached a different conclusion or result than I did. What I tried to do initially and successfully was having them pull. So, of course, with every feature that you want to implement, the ideal way is to have a proper GitHub issue to track the feature, the implementation history, and all of that, right? So I would have the implementation agent post a status update, essentially just using the GitHub as a ledger for statuses on this particular issue. If the implementation agent is done, it would post a status update to the GitHub issue, and the ledger would show, oh, implementation is done. What does that mean? That means the reviewer needs to step in. And the reviewer would be polling consistently the ledger, and I set the polling frequency to once every 10 minutes, timeout after 30 polls. You can do whatever you want. And as soon as the polling agent sees that the implementation status has changed, then it starts reviewing, and it would then post a new status update after it finishes reviewing with its review findings, and so on and so forth, right? So in theory, as you can see, it's just two agents polling against a singular structure, a singular ledger, so that they can coordinate with each other what to do. This is actually one of the valid models that you can use when it comes to writing C code in parallelization. Like if you're trying to have a multiple multi-thread application, that's one of the things you can do. Have a shared messaging bus, and then you can then figure out different work that you can do with each other, so that you don't spin deadlock on the same thread. But that's where the inspiration came from. The problem with this is that in practice it doesn't really work very well, because agents are not deterministic. So at some point, and I haven't figured out a way to prevent them from doing this, at some point they would stop polling, or worse yet, they would think that they're polling, but the process that they're using to poll has died, and they're not aware of that. And when there's just too many exceptions in this fragile polling approach, where I was trying to fix this exception after that exception after that exception, but after, like, every single time after all these things are fixed, there's a new exception that would come up that would prevent the polling from successfully sort of continue. And this became a very frustrating experience. So after I think 3 or 4 fixes, I'm like, screw this, I'm not looking to do this. And then I discovered, and I didn't discover it right after my frustration with this. I knew about this, and I just didn't sort of incorporate it in my original thought. I could use subagents. Both Codex and Claude Code have this feature, subagents, where you can ask the main thread, the main agent, to summon subagents, agents that report to them to do particular things, bounded things. And the great part about this is that because they're new subagents, and this is also a drawback because this is something that you can't do, they have fresh new context. Sure, they inherit your global agents file, but their context is not polluted by the implementation agent. So what this means is that you can just use your main agent, your main thread, as the orchestrator, and have the orchestrator summon implementation agents, review agents, and deployment agents, right? And every agent would have a fresh new context without polluting each other, and thereby giving you the best quality when it comes to implementing, reviewing, and deploying. There is another benefit from doing this, which is because you're not just using the same agent for everything else, you could actually use cheaper, more efficient, and faster agents for easier tasks. My experience has been that the design agent, the agent that you go back and forth when it comes to coming up with a product design, the new feature, and then new toggles, new new UI elements, that needs to be high intelligence, because it needs to sort of understand what you want, translate that to product decision, go back and forth with regards to refining what this feature needs to be. That requires a lot of intelligence. But after you've finished a product design, going from product design to implementation design, that's a much smaller gap, because you already have what you want the product to be. That's the hard part. And translating that to a plan that puts the code, it's not implementing yet, it's just translating that to a plan, sort of like a GitHub issue. That's a much smaller gap. So for that, I've discovered I can use one step down. I use Terror, and I believe the thinking level is high, or X high, I believe. And I found that to be consistently good. So in other words, I don't have to pay for Sol, the top tier model, when it comes to this translating to the issue. And then from the issue, from the GitHub issue, from the plan, from the implementation plan to the actual code, that's an even smaller gap. Now, granted, in the past, software engineers are paid to do this step, right? Translating from an issue, a plan, to the code. And that's where genius software engineers are, like, at least a big chunk of their expertise is used. Maybe not genius, maybe junior. You get the idea. This is a much smaller gap. And with this gap, you can downgrade the intelligence of the model even more. So I've been using Luna X High. Luna is the lowest tier model OpenAI currently offers within their codex. And this is not only very, very fast, but also very, very cheap. It barely moves my usage meters, even when working on large code bases and large like file implementation, like a dozen files. And after the implementation, then you can have a reviewer. The reviewer agent needs to be intelligent, because I'm not just asking the reviewer to review the implementation correctness, because that's something that the Codex Cloud-connected reviewers would actually do. I would want the reviewer to review holistically, not just the implementation, but also whether or not this implementation fixes the problem that it was looking to fix. In other words, the scope is bigger than just, oh, did you use this function correctly? And that requires high intelligence. So I go back to Sol for the reviewer agent. And not only that, another important piece of judgment that the reviewer agent needs to do is whether or not the implementation agent needs an intelligence upgrade. If this issue turns out, this implementation plan turns out to be much more complex than I originally anticipated, than really anybody had originally anticipated, it wouldn't be immediately obvious to you when you're trying to implement this GitHub issue. You don't, how would you know? Unless you start doing it, you wouldn't know. So the first pass, you would have Luna X High very cheaply go through the implementation, and barely costs anything. And once Luna finishes and the implementation agent discovers that, hey, this turns out to be a very complex issue and Luna keeps making silly mistakes here and there, it can then make a judgment call to upgrade the implementation agent to the next tier in terms of intelligence and thinking level, such that you have this kind of a low cost to no cost first. Again, Luna is so cheap, you can just keep using it. And the only cost is a little bit of time, but because Luna is very fast, you don't have to worry about too much time wasted here. And it can do 80 to 90% of the implementation. And for the last 10 to 20%, the review agent can make a judgment call and then upgrade the intelligence such that you can actually get your job done. So that's the power of using subagents for implementation and review. And this is not something that's easily reproducible in a separate sort of codex window, implementer and reviewer window, because again, you're wasting your cycles to sort of babysit those two agents. And not only that, the judgment call regarding whether or not the implementation agent needs an intelligence upgrade is something that you can't really easily do unless you dig into the code yourself and find all the sort of corroborating evidence regarding the lack of intelligence when it comes to the implementing agent. You would actually have to ask an AI to do that, unless you want to waste a lot of time doing that yourself. And this means that the two-window approach compared to the automated subagents becomes just woefully inefficient. And that's really the theme for this particular video, which is, if you haven't used subagents, well, first of all, if you haven't started using this implementing, review, fix process, you will need to start doing that. If you do that, you'll find a great deal of improvement to the quality of the code that you generate. And this is not just me talking about this. There actually has been studies performed on AI agents when it comes to code quality. It significantly improves with reviewers. And this is very strange, isn't it? Because you might think that the AI agent can just come up with things that it's perfect. No, they can't. They have to be reviewed. So if you're not using this review process, start doing that. Even do it manually. Once you start doing that manually for a little while, discover that it's quite tiring to babysit it. So you can automate it using subagents. So that's the what and the why. But how do you do that? Very, very simple. These are instructions codified in the agents file. That's essentially you telling the agent, oh, when you are going to implement this, use a subagent with this intelligence level, with this thinking effort, and give it this context to do this implementation. Have it post it here and there, and then hand off it to hand off the result to a review agent, which is this model, this thinking level, blah, blah, blah. Really just deterministic, sorry, not deterministic, instruction file that you create or you edit to include the instruction for the agents to start using subagents. One little neat trick that's important to keep in mind is that there is actually a deterministic way to invoke any particular workflow or any subagents in the agents file. If you define it with the $ in front of any particular workflow name, if you use the same $ and the name after it, for mine is reviewed change, $ reviewed change full. If I do that, then the agent wouldn't make any judgment call. He would immediately invoke the deterministic workflow that includes all the subagents that I've specified. In other words, you can, even in the AI workflow, you can make something deterministic within the harness of Codex. It's pretty convenient. In any case, if you have any questions, feel free to leave your comment, and don't forget to give it a like and share. Thank you so much. This is it for this week. I'll see you next week.